Welcome to this YSL Excel VBA tutorial. In this part of our series on writing SQL for Excel files, we're going to cover the basics of writing inner joins. So we're going to start with a quick primer on relational database basics to understand why you need to write joins in the first place. We'll then explain how you can write a basic inner join to put two tables together and look up values between them. We'll look at how you deal with duplicate column names between the tables you've joined. We'll show you an alternative syntax to join tables without using a join, and then finish the video by joining multiple tables together and using the columns from all those tables in various parts of your select statement. So let's get started. If you've been watching previous parts of this series, you'll already know about the basic setup by now, so feel free to skip to the next chapter of the video without missing anything important. If you haven't seen previous parts of the series, here's a quick overview of how things work. We have a macro-enabled workbook called Inner Joins, and this has some code which allows us to run a query by clicking this button to extract data from a separate Excel file called Movies. The Movies workbook has various worksheets containing information about films and related information. I'll keep this workbook open for the duration of the video just so that I can point out the various features as I talk about them, but you're welcome to close down the Movies workbook and all of the code will still work. I've got both of those files stored in the same folder, and I'll drop a link in the video description so that you can download the same two files and follow along with writing the code if you'd like to. A lot of the code in the Inner Joins workbook relies heavily on Microsoft ActiveX data objects to create the connection to the external workbook and retrieve the data. That part isn't something I'm going to talk about in this video. This series is about the SQL query side of things. So if you are interested in ActiveX data objects, we have a separate playlist which has videos which cover those topics. So the Excel VBA Working with Databases playlist, I'll drop a link to that in the video description below as well. And then I'd recommend starting with this video, how do I get data from a closed Excel file using VBA? Just to demonstrate the code working, if I head back to the Inner Joins workbook, when I click the Run Query button, it triggers a subroutine called Create SQL Query. And all this one does is basically constructs the SQL query by concatenating strings of text to form a select statement. So at the moment I'm just going to select three columns from the film table of the Movies workbook: title, release date and director ID. When I've constructed that query, it then gets passed into a separate subroutine called getQueryResults. That's sitting just below here. And this is the one that deals with establishing the connection to the Movies workbook and then creating the record set to extract the information. The query that we've constructed gets used in this line here to populate the source property of a record set object. Then there's a bunch of extra code here which deals with extracting the information and writing it out into a new worksheet in the Inner Joins workbook. So if we just have a very quick look at running that one, if we head back to the menu sheet in Inner Joins, run the query, we'll get a new worksheet listing out the three columns that I've requested. So I've selected the title, release date and director ID for each film in the film table. But the director ID isn't a particularly useful piece of information for me to read as a human being. I don't want to, for example, read the fact that Batman Begins was directed by 27. That's completely meaningless to me as a human being. I want to know the name of the person who directed Batman Begins and maybe their date of birth and possibly other details as well. The reason I've got the list of numbers for the director IDs rather than the director names is because in the Movies workbook in the film table, the director name isn't actually stored. Each film only records the ID number of the director who directed it. If I want to know the details for who directed Batman Begins, I'd have to take the number 27, head over to the director table, find the director ID column and then look up in that column the number 27. And once I've done that, I can return any details from the same row. So it's basically like an elaborate VLOOKUP function if you want to think of it in those terms. This design pattern, the reason things are done like this is that it's a design pattern common to relational database design. One of the advantages of this design pattern is that it reduces unnecessary duplication of data. Christopher Nolan has directed quite a few films and some of them are in my film list. And if we had to store all these details about Christopher Nolan every single time we record a Christopher Nolan film, that's quite wasteful in terms of storage space. As I say, this design pattern is common to relational database design, slightly less common to find this pattern in Excel, I admit. But it's a nice easy way to introduce the concept of writing joins, and we're going to use joins to do some more Excel relevant things in later videos in this series. just to try to help understand how things are related. So we've got lots of ID columns in the film table, as you can see, and each one of these ID columns has a corresponding table into which we can look up the related information. And I've drawn a little diagram on a separate worksheet to try to help understand how things are put together. So taking the director table example, the director table has a director ID column, and I've indicated that this is a key or a primary key column. So the little gold key symbol here indicates that each director ID exists once and once only in the director table. So we know we haven't duplicated any directors because they can only be stored once. Then there's a relationship between the director table and the film table, specifically between the director ID column in the director table and the director ID column in the film table. The little silver key symbol here indicates that this is a foreign key. So this is a column in one table which takes its information from a key column in another table. The silver key, a foreign key, can appear many times in its table. So if I have a look at the film table and I look at the director ID column, you can see here already that there are duplicates of director IDs. The same numbers appear multiple times, each time a director has directed multiple films. So we have, in what's called in database design terms, a one-to-many relationship. So one director can direct many films. And that same principle holds true for all of the other similarly indicated relationships in this diagram. What we need to do, of course, is write some code in our SQL query to automate the lookup process of taking the number 27 from the film, following the relationship back to the director table to retrieve the human-readable, useful pieces of information about the person who directed the film. So let's have a look at the basic pattern of code we need to write whenever we want to join another table to the existing list in the from clause. I'm going to head to the end of the existing from clause and then just concatenate a continuation character. And then on the next line, I'm going to open up some double quotes and type in the words inner join. There are various types of joins you can write in SQL, and we're going to encounter a few more of those as we work further through the series. This video is going to focus on the most basic type of join, an inner join. For those of you familiar with a different dialect of SQL, such as Transact SQL in Microsoft SQL Server, in this dialect of SQL, the inner keyword is compulsory. You can't miss that out. In some dialects, you can just say join, but here we must say inner join. Then we need to write the name of the table that we're joining. So in some square brackets, I'm going to say director $, because it's a worksheet. And then I'm going to assign an alias to it, just like I have with the film table, to make it easier to reference its columns later on. I'll call this one as D. Then we have to say which columns are involved in the relationship the tables are being joined on. So we know that the column name is the same in each table. If we have a look back at the diagram, it's director ID to director ID. If we look at the film table, there's a director ID column there and a director ID column in the director table. So we need to indicate that by saying on f.directorID is equal to d.directorID. So it's kind of almost like adding a where clause to the from clause. You're adding a condition to say join these tables on the condition that the director ID value in the film table is equal to the director ID value in the director table. So now that we've included the extra table in our from clause, we can access any of its columns in other parts of the select statement. So let's do a simple example. In the select list, we'll include the director ID column from the director table, just to prove that the values are the same. And then we'll include, let's say, the full name, so we can see the name of the person, and maybe the DOB as well, so we can see the date of birth. So back in the VB editor, we can simply extend our select list. Let's copy and paste to save a little bit of time. So I'm going to copy and paste the f.directorID column and then update the alias at the beginning to say give me the ID from the director table instead. This is absolutely not necessary, by the way. We don't need to show the director IDs to join. This is just for demonstration purposes. We'll get rid of these eventually. Then let's paste that line in again, and I'm going to change the alias to say D, and then we'll refer to the full name column. And then one more, we'll paste that in again and change this to say d.dob. Okay, so having done all of that, we can head back to the menu sheet in the Inner Joins workbook, click the Run Query button, and we'll get data from both tables we've joined together with the matching values in the director ID columns and then the relevant details for that director written out into the next two columns. Now, there are a few important things to note about the way we've identified the columns in the two tables we've selected from. We have a combination of different column types now. Some have unique names within all the columns in all the tables, so title, release date, full name and DOB have unique names. Director ID, however, is duplicated, and you can see that that's been indicated which table these columns are being selected from with a little table alias at the beginning in the column name. Now, it's really important that we distinguish between the duplicated column names in our select statements. Let's just head back to the Visual Basic Editor. I'm going to make a few changes to this query but come back to the original version a little bit later on. So I'm going to at this point make a copy of the entire thing and then just paste it in somewhere down below. And then I'm going to comment out the original version just by typing an apostrophe at the beginning of this SQL query line. Okay, so let's try removing the alias from the uniquely named columns. If we say title, release date, full name and DOB, that will be absolutely fine. If we head back to the Inner Joins menu worksheet and run that query, that will work perfectly happily with no problems. So we've actually done a little more work than was absolutely necessary by identifying which table those columns belong to. Things don't work quite so smoothly, however, if we don't identify the table to which the director ID column belongs. If I take away one or both of the aliases, how does the query know which director ID column I mean? So if I head back to the menu sheet, the answer is it doesn't, and it tells me that in no uncertain terms. It tells me that the specified field director ID could refer to more than one table listed in the from clause. So it's quite a nice descriptive error. So that's the reason for identifying the column names or the tables to which a column belongs to in the first place. When you have duplicated column names in all the tables you've selected, you must specify which table those columns belong to. When you have columns with duplicated names in different tables, you have to qualify the reference to that column whenever you reference it in your query. So again, here in our from clause, we've referred to the specific table to which these columns belong. And again, if I remove those aliases, those qualifiers to the director ID column name, the query simply doesn't work at all. If I try to run the query, it fails completely this time. Join expression not supported. This leads me on to the point of creating table aliases in the first place. We've been using table aliases from virtually the first query we've written in this series, but it's never really been necessary up to this point. Here it provides quite a nice advantage. If we didn't have the table aliases as F and as D, the only choice we have now to distinguish between the duplicated column names is to precede each column with the full name of the table followed by a full stop. And you can imagine how long and detailed this query will look, how awkward it will be to read if we have to precede every single reference to the director ID column with the full name of the table to which it belongs. I'm doing a little more here than is absolutely necessary just to kind of hammer home the point I'm trying to make. But if you compare this query here, it will work, of course. Let's just run it just to prove that. If we've referenced the names of each column explicitly with the table name, everything will work happily again. But if you compare the look of this query compared to the look of the previous one we wrote with the table aliases, I think this is much simpler and easier to read, much more succinct style. Your mileage may vary, of course. I'm not trying to force you to go one way or the other. Feel free to use whichever technique you're more comfortable with. The single important thing, of course, is that we always distinguish which table a column belongs to when you have multiple tables containing the same column name. Just before we move on and start adding more joins to the same query, I want to talk about a slightly different way to achieve the same end results without using joins at all. At a basic level, I suppose, a join is really just a way to include a criterion to check where the value of a column in two different tables has the same value. There are a few more clever things, of course, that we can do with joins, as we'll see in later videos in the series. But for this video, let's just assume that it was a simple way to add a simple criterion. Now, if you've been watching previous parts of the series, you'll already know that there's a place in a select statement to add criteria into the where clause. So, rather than using joins to put these two tables together, let's take away the words in a join and replace those words with a simple comma. Much like we comma separate the list of columns in the select list, we can comma separate a list of tables in the from clause. Then I'm going to take away the on statement altogether, so I don't need that at all. Then, at this point, I'm going to try to run the query. It's going to take quite a while to run, by the way, and please feel free not to do this if you don't want to. But I'm just going to head back to my inner joins workbook, head to the menu sheet, and click the Run Query button. And you can hopefully see it's taking a lot longer to run than previously. It was virtually instantaneous last time. Oh no, have I killed Excel? No, it's come back. Fabulous. It will eventually respond, I hope. I haven't killed Excel. There we are. Marvellous. Excellent. I've got my set of results. But it's a slightly weird set of results. Hopefully you can see, because I haven't added a criterion to say only show me the rows where the film's director ID is equal to the director's director ID, what this query has done is matched every single film in the film table against every single director in the director table. So it's listed out Jurassic Park, first of all, once for every single one of the 200 or 300 odd directors. I can't quite remember how many there are in the director table. Let's find out. We'll see when we switch from Jurassic Park to the next film in the list. Oh, a few more than that, in fact. Maybe there are more. Oh, 400 odd. There we are. So, when we finish with Jurassic Park, then it moves on to Spider-Man, and lists Spider-Man next to every single director. So we've got 1,200 rows multiplied by 487 rows, meaning we end up with nearly 600,000 records in this result set, which is why it took so long to run. Not particularly helpful. Well, actually, there are some occasions where that type of thing is useful. We'll see some later in the series. Anyway, to solve that particular problem, we need to re-include the criterion that we wrote to make sure that we only find rows where the ID field, director ID field, is equal. So I'm going to concatenate a continuation character to the end of that query, add the where clause, add another continuation character, and then in some double quotes, I basically need to replicate this criterion. So director ID equals director ID. So I'm going to cheat slightly and copy and paste that one from the previous query that we commented out. And then because I haven't provided an alias for this one, I'm going to have to just quickly copy and paste the table names. I still need to distinguish between the tables that those columns belong to. Okay, so having done that one, let's head back to the menu sheet. Oh, wrong workbook. Inner joins, menu, click the Run Query button, and it will be much quicker again now, and we should end up with a list of 1,200 films that we'd expect based on the IDs matching. Okay, so now we've seen two different ways to join two tables together and get the same set of results. We can either just write a comma-separated list of tables and put criteria in the where clause, or we can write the slightly more complicated join syntax just in the from clause. You're probably already forming a preference at this point, and I'm not here to sway you one way or the other, but my personal preference is to use the join syntax. The main problem with adding all of your criteria in the where clause, imagine eventually, as we will, join in all of the other tables, the studio, country, language, genre, etc., into the film table in this query. That means your where clause is going to have a criterion for each individual table that's joined in. And then you might want to add more criteria to say, well, show me only the Oscar-winning films, or show me the films in a particular genre, or released between two dates. And then your where clause is going to get very complicated, because you'll have to make sure that all of your table joining criteria work, as well as all of the row criteria. I prefer to make sure that everything involved in joining a table into the query is involved in the from clause. I know exactly where it is, and I don't have to worry about that in any other part of the query. There are also a few more clever things we can do with joins, as you'll see in subsequent videos in the series. So we'll talk about the different types of joins available and how you can use those to see different sets of data, which are somewhat more complicated to do if you're just using simple criteria in the where clause. So for the rest of this video, as it's all about joins, I'm going to remove the second version of that query. And I'm going to head back to the first one with our nice join syntax and the table aliases. As I say, we don't need to see the director ID columns in our select list, so let's just take the opportunity to tidy up a little bit, remove the 2 references to the director ID column in the select list, and then we'll just check that everything is working neatly again if we head back to the menu sheet in the inner joins workbook, run that query, and there we are, the original set of data we really wanted to get. Okay, so now that we know the basic pattern for writing joins, we can move on and start including more tables in the same select statement. So let's, for the next example, try to include the genre table in our select statement, so we can see the name of the genre next to each film, rather than just the ID number for that. So again, looking at the diagram, we have the same basic arrangement. The genre table has a primary key column, genre ID, which is related to the foreign key, genre ID, in the film table. So we want to look up the genre ID to return the genre name. Nice and easy. Let's head back to the Visual Basic Editor, and at the end of the existing join, in fact, let's just copy and paste the entire join line. I'm going to type in a space after the reference to the director ID column just at the end first, and then I'm going to copy the entire inner join line, concatenate a continuation character to the end, paste that line in, and then just start updating the reference to the director table to refer to the genre table instead. So I can give it a different alias, genre as G, and I want to refer to the genre ID field in the film table and the G.genre ID field in the genre table. And I'll attempt to spell that correctly as well. By the way, it doesn't matter whether you refer to the film table first followed by the genre table or the genre table followed by the film table. You're asking if one thing is equal to another, so it doesn't matter which way round you do that. Let's just include a value from the genre table then in the select list, so we can add a new line there, and we can say g.genre. And then we can concatenate the continuation character to make that complete. Okay, so everything looks good. But sadly, this isn't going to work. Let's just prove that. If we head back to the inner joins workbook, head to the menu sheet and run that query, it fails. It doesn't give us much help either. It just gives us a generic syntax error in query expression, specifically to do with the join that we've just added. But there's nothing wrong with that join. It's absolutely perfect, the join itself. If we have a look at the code, it follows exactly the same pattern as the previous one. If you had written this in another dialect of SQL, such as Transact SQL, this would have worked perfectly happily as well. The problem here is that with the dialect of SQL we're using to talk to an Excel workbook, when you include multiple joins, it doesn't know which one to do first, basically. And we need to provide a little bit of help to tell it to join one table to the film table first, and then join the next table to the results of that. It's a little bit like controlling the calculation order when you involve multiple multiplications and divisions and additions and subtractions in the same expression. So here's a tip. We know that this part works already. We know that we successfully joined the film table to the director table to produce a table of results. So let's wrap a set of round brackets around the join that we know already works. Now that we've done that, it will perform that join first and then join the genre table to the results of that join. And now that we've done that, if we head back to the inner joins workbook, hit the run query button, it will now run and return the genre to which each film belongs. Okay, so now that we know that, we really can just follow the same pattern to start including the other tables that we want to join into the same query. So let's head back to the diagram. I want to bring in the studio table, the country table, etc. So the pattern is exactly the same from this point, back in the Visual Basic Editor. I know that this combination of joins already works, and I want that to happen first, so I'm going to open a set of round brackets at the very beginning of the from clause, and then close a set of round brackets right at the end. I'm then going to copy that line, and I'm going to add a continuation character to the end, paste that in at the on the next line, and then just get rid of that extra round bracket that I've just added. So let's call this one let's go for the country table next. So we'll say country as C on f.countryid equals c.countryid. And then in my select list, I can refer to a column from the country table by saying c.country and add another continuation character. Then let's just check that that one works. If we head back to the inner joins menu sheet, run the query, we get the country names included in the next column. So from this point on, everything else is incredibly repetitive. It's following that exact same pattern for each subsequent table we want to join. Rather than bore you even more than I already have, I'm just going to bring in two more tables. Let's go for the studio table and the certificate table. So back in the Visual Basic Editor, I'm going to copy and paste from the end of the previous line the continuation characters and then the join on the next line. Paste that in after I've joined country. And I know that the join up to the country table already works, so let's wrap that set up in a set of round brackets. And then we can modify the name of the table we're selecting from. So let's go with the studio table next. We'll call that one S. Join that to the studio ID based on the studio ID column. So f.studio ID to s.studio ID. And then we can add a column from that table into the select list. So we'll say s.studio ID. Oh, sorry, beg pardon, s.studio. I just want to show the name of the studio. And then one more table to bring in. So I'm not going to test this one. Let's be a bit more confident. Let's wrap that set of joins in a set of round brackets. And then we can copy and paste that line and the continuation character. Ooh, just get rid of the extra round brackets right at the very end. And we'll include the certificate table, if I can spell it correctly. Let's just copy and paste it so I don't have to type that in again. One small problem with the certificate table, ideally I'd like to alias it as C, but I've already used that one, so I'm going to call this one CE instead. So we'll say f.certificate ID to ce.certificate ID. I can then finally include an extra column from the certificate table in the select list and concatenate that with a continuation character. And then the moment of truth, if we head back to the menu sheet, run that query once more, we should get the combination of columns from all of the tables we've joined together in one single query. So once you've joined in all the tables you want in your query, you can build the rest of it in just the same way we've discussed in previous parts of the series. So we can change the sort order by adding an order by clause, we can add a where clause to filter out the rows we're not interested in, you could group and aggregate the data, you can include expression columns, everything else is the same, you just now have access to more columns because you've joined all the tables together. So just to perhaps tidy up a little bit, we'll add a couple of extra bits and pieces to our query. I'm going to head back to the VB editor and I'm going to start by adding a where clause that will only show the films with at least one Oscar nomination and from a country whose name does not begin with the word United. So I'm going to concatenate a continuation character to the end of my from clause and then add a where clause and then concatenate another continuation character below that. And I'm going to ask where f.nominations is greater than 0. And I'm going to go down to the next line again with a continuation character, c.country, not like United followed by a percentage symbol. And if you're not quite sure what all that means, then we've got other videos which talk in lots of detail about adding criteria to queries using different data types. Just so we can see clearly that that is working, I'm going to change or add in an extra column into my select list. So I'm going to add in comma f.nominations so we can clearly see that the film has been nominated for something. And then we could add an order by clause as well. So let's add another continuation character to the end of the query and add an order by clause. And this time we'll order by, I've got my continuation character, sorry. We'll order by the genre first of all. So I'm going to go with g.genre in ascending order. And then I'll go with c.country, also in ascending order. I'll just do all this on a single line rather than separating it all out. And then finally, f.title, too many full stops, f.title also in ascending order. Okay, so that's the entire thing done. Let's head back to the menu sheet and run that query one more time, and we will end up with a beautifully formatted, filtered, sorted set of results based on data from multiple tables in one single query. So there we go, there's the absolute basics of using joins to look up values in related tables. We'll be using joins a lot more in the subsequent videos of this series to do much more interesting things than what we've done here, so hope you're looking forward to those videos. Thank you very much as always for watching this one. We'll see you next time.